Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's topic, please do subscribe my channel. So my dear students, today I'm going to give you some introduction to the atomic structure, the different models given by different scientists in their respective years, some information about the electron, proton, the neutron, isotopes, isobar, isotone and the isodiaphers. Before starting today's topic, let's talk about what exactly do we mean by atomic structure. So I'm writing the arrangement of electrons, protons and neutrons in an atom is called its atomic structure. Is called atomic structure. The first atomic model was given by Dalton in 1808. The first atomic model was given by Dalton in the year of 1808. After that, the second model was given by Sir J. Thomson in 1898. The third model was given by Rutherford in the year of 1911. Then some drawbacks were there in Rutherford, so the next improved model was of Niels Bohr atomic model in the year 1913. Then some drawbacks was also there in the Bohr atomic model. Then came de Broglie model. De Broglie model in the year 1924, and then finally some drawbacks was also there, so finally came the model which we are following today. It was the concept of orbitals that was given by Robert Mulliken in 1932. So these were the different models given in the different years because of drawbacks in the previous model. So before starting next topic, now let's talk about some basic terms, that is atomic number, the mass number. Let's talk about it. So I'm writing my first term to be atomic number. I'm writing atomic number. What do we understand by atomic number? It is actually the number of protons present in the nucleus or it is the number of electrons, or it is the number of electrons revolving around the nucleus. Revolving around the nucleus. That stands for atomic number. Now, the atomic number is represented by a capital letter Z. The atomic number is represented by the capital letter, that is Z. Now, I am writing number of neutrons plus number of protons. The sum of number of neutrons and the number of protons is called nucleons, and the number of nucleons or the sum of number of neutrons and the number of protons is also called atomic mass or simply mass number. So let's talk about nuclides. I'm talking about nuclides. What do you mean by nuclides? The sum of all subatomic particles, that is number of electrons plus number of neutrons plus number of protons. The sum of all the subatomic particles, that's electrons, neutrons and the protons, is called nuclides. Now, next is mass number. We have already done that. The mass number is obviously the number of protons in nucleus plus the number of neutrons in nucleus. Now the mass number is represented by a capital letter A. The mass number is represented by a capital letter A. So I'm going to give you a representation of an element. How do we represent an element? Now I'm going to tell you about representation of an element. I'm taking an element to be chlorine. Let's talk about chlorine. Let's have first of all a demo element. I'm talking about, I'm having an element X. In the X, the mass number is represented at the left top corner, means A over here, and atomic number is mentioned at the bottom left corner, that is Z over here. Now let's take an example of chlorine. I'm taking an example of chlorine. What's the atomic number of chlorine? It's 17. What's the mass number of chlorine? It's 35. So this is the representation. Here, if I need to calculate the number of neutrons, then to evaluate the number of neutrons, the formula is the mass number minus atomic number. What's the mass number? 35. What's the atomic number? It's 17. So mass number minus atomic number, 35 minus 17 comes out to be 18 neutrons. That means in chlorine we have number of electrons to be 17, the number of protons to be again 17, and the number of neutron comes out to be 18. So this is the representation. I have told you about the atomic number and the mass number. Now let's talk about electron, proton and a neutron. Now, my dear students, I'm giving you some information about electrons, protons, and the neutrons. So, first of all, electrons. Let's talk about electron. Electrons was firstly discovered by Sir J. Thomson. J. Thomson in the year 1897. In the year 1897. The protons were discovered by Goldstein. The protons were discovered by Goldstein in the year 1909, and the neutrons were discovered by James Chadwick in the year 1932. That's 1932. So these were the scientists who have discovered the electron, protons, and the neutrons in the respective years I have also mentioned. So let's talk about first of all electron. Firstly, I am mentioning the mass of electron. The mass of electron is 9.11 into 10 to the power minus 31 kilograms. Now, charge on electron. The charge on electron has a value of minus E. The minus E stands for minus 1.6 into 10 to the power minus 19 coulombs. Now let's talk about protons. What's the mass of protons? The mass of proton is 1.00728 AMU. You can round off it to only 1 AMU. So now what is 1 AMU? The atomic mass unit. The atomic mass unit is the 1/12th mass of carbon 12 isotope. What is the AMU? It is exactly 1/12th mass of carbon 12 isotope. So the mass of proton comes out to be 1.66 into 10 raised to the power minus 27 kilograms. Now let's talk about the charge on proton. The charge on proton is plus E. That's my charge. The plus E is my charge and minus E is also my charge. The charge of proton is plus E, that is it's plus 1.6 into 10 to the power minus 19 coulombs. Now let's talk about the neutrons. So what's the mass of neutrons? It's again mass is 1 AMU. So exact mass of neutron is same, that is 1.66 into 10 to the power minus 27 kilograms. And the charge on charge on neutron. So the mass of neutron comes out to be 1.66 into 10 to the minus 27 kilograms, and the charge on neutron comes out to be 0. So I have talked about the electron, proton, and the neutron. Finally, I have talked about neutron. The mass of neutron comes out to be 1 AMU. It's 1.66 into 10 to the minus 27 kilograms, and the charge is 0. So let's talk about the ratio of the mass of electron and the mass of proton. The mass of electron is 9.11 into 10 to the power minus 31 kilograms divided by the mass of proton is 1.66 into 10 to the power minus 27 kilograms, and this value comes out to be 1 divided by 1837. It signifies that the mass of proton is 1837 times the mass of electrons, means proton is 1837 times heavier than the mass of electron. So when we talk about the mass of an whole atom, we usually talk about the mass of nucleus only, because the mass of electron is negligible as compared to protons and that of neutrons. So let's talk about the mass of an atom. So firstly, I'm mentioning that the proton is the proton is 1837 times heavier than electron. Proton is 1837 times heavier than electron. So when we talk about the exact mass of an atom, then the mass of electrons is negligible, because they are much lighter than protons and the neutrons which are present in nucleus. So in practicality, we are talking about the mass of the nucleus only. So I'm giving you the example. Let's talk about copper. The atomic number of copper is 29 and its mass number is 63. So what will be the mass of copper? Mass of copper will be, I know that 63 is the sum of the number of protons and the number of neutrons. Now the mass of one proton or neutron is equal, that is 1.66 into 10 raised to the power minus 27 kilograms. So that comes out to be the mass of copper, or it is also the mass of nucleus of copper. Now let's talk about the charge on nucleus. If I'm talking about charge on nucleus, then how you have to calculate it? How many protons are there in copper? There are 29 protons. What's the charge of one proton? It's 1.6 into 10 raised to the power minus 19 coulombs. You will get the exact charge on the nucleus of the copper. So that's all about the mass number, atomic number, the electrons, protons and the neutrons. Now let's move to the next topic, that's isotopes. So now let's talk about isotopes. First of all, what do we mean by isotopes? I'm writing, these are the atoms of same element. These are the atoms of same element having different mass number. Having different mass number. So let's talk about it with some examples. I'm taking an example of hydrogen. I'm writing hydrogen, hydrogen and hydrogen. What's the atomic number of hydrogen? It's 1. It's again 1 and 1. Now, what's the mass number of hydrogen? It's 1. When it's 1, then this is called protium. Now, when the mass number is 2, then it is called deuterium. And when it's 3, it is called tritium. Now, my dear students, let's calculate the number of neutron in these three. I am writing number of neutrons. In the first case, in case of protium, the number of neutrons will be, the formula is A minus Z. It comes out to be 1 minus 1 and it comes out to be 0. So it's a very important term that only protium is the element in the whole periodic table who does not have any neutron. So protium or hydrogen is the only element in periodic table who is having 0 number of neutrons. Let's talk about the deuterium. The number of neutrons comes out to be, it's 2 minus 1. So here are 1. Now in case of tritium, number of neutrons, it comes out to be 3 minus 1 and it comes out to be again 2. So it's 2. The number of neutrons in tritium is 2. Number of neutrons in deuterium is 1. And in case of protium is 0. Now this is my first example. Okay, let's take some another example. Now I'm talking about chlorine. We are having 2 isotopes of chlorine in the nature and I'm writing them. It's chlorine and chlorine. Now the chlorine has an atomic number of 17 and 17 and the mass number for chlorine is 35. That's my first isotope and the second one is 37. Now the number of neutrons in case of chlorine is, it's 35 minus 17 comes out to be 18. So here the number of neutrons comes out to be 18, and that of 37 isotope, the number of neutrons is 37 minus 17 comes out to be 20. So we are having different number of neutrons in case of isotopes. So hopefully my dear students, you got this. In case of protium we were having 1 neutron. In case of deuterium we were having only, in case of protium we were having 0 neutrons. In case of deuterium we were having 1 neutron, and in case of tritium we were having 2 neutrons. So that's my isotopes. So what are the isotopes? First of all, these are the atoms of, the very important term, these are the atoms of same element which have different mass number. Now the same element stands for, which have same atomic number but different mass number. So what are the isotopes? These are the atoms of same element. That means they have the same atomic number but they have different mass number. So hopefully my dear students, you got the isotopes. Now let's talk about the isobars. Now I'm talking about isobars. Now what are isobars? These are the, first of all, atoms of different elements. These are the atoms of, first of all, different elements, obviously they will have different atomic numbers. Having different atomic numbers but same mass number, but same mass number. So what are isobars? These are the atoms of different elements having obviously different atomic number, but they will have the same mass number. Let me take an example. Here I am taking an example of two elements, that is argon and calcium. Now, what's the atomic number of argon? It's 18. What's the atomic number of calcium? It's 20. Now, what's the mass number of argon? It's 40. And what's the mass number of calcium? It's again 40. So you can observe that argon and calcium have different atomic numbers, but they have the same mass number, that is 40. So what's common in them? Obviously the same mass number, or you can say that the sum of protons and neutrons is common in both of them. They will have a different number of protons and a different number of neutrons, but the sum of protons and neutrons will be the same. Let me calculate this thing for you. Now, the number of electrons in argon is 18. So the number of protons will also be 18. So the number of neutrons will be 40 minus 18, and it comes out to be 22. And in case of calcium, we are having the number of electrons to be 20, the number of protons also 20, and the number of neutrons comes out to be 40 minus 20, and it comes out to be 20. So now let's calculate the sum of protons and the neutrons. That is protons plus neutrons, that's called mass number. What's the number of proton? It's 18. And what's the number of neutrons? Is 22. It comes out to be 40. And in case of calcium, the number of protons and number of neutrons, proton are 20 and the neutrons are also 20. So 20 plus 20 comes out to be 40. So protons plus neutrons is called the mass number of the nucleons, and it will be equal in case of isobars. So isobars are the atoms of different elements having different atomic number but same mass number. Hopefully, dear students, you got the isobars also. So now let's calculate the next topic, that's isotones. So now let's talk about isotones. I'm writing isotones. What is isotones? Again, first of all, these are the elements. These are the elements of, again, different elements. These are the elements these are the atoms of different elements. Let me write a definition again. What are isotones? These are the atoms of different elements having same number of neutrons, having same number of neutrons. Let me take an example for you. In case of isotones, I'm taking three elements. The first one to be oxygen, the second one to be nitrogen, and the third one to be carbon. So what are the atomic number of oxygen? It's 8. That of nitrogen, it's 7, and that of carbon is 6. Now let me write the mass number. For oxygen it's 16, In case of nitrogen, I am taking the heavy isotope with the mass number of 15. And in case of carbon, I am again taking the heavy isotope with a mass number of 14. So let us calculate the number of neutrons in all three. Now, the number of neutrons will be obviously A minus Z. For oxygen, it comes out to be 16 minus 8, and it comes out to be 8 neutrons. In case of nitrogen, it will be 15 minus 7, and comes out to be again 8 neutrons. And in case of carbon, it will be 14 minus 6, and it again comes out to be 8 neutrons. So in these three, we are having the equal number of neutrons. That's why we will call it isotones. So that's my isotones, isobars, isotopes. Now I'm left with the last topic, that's my isodiaphers. Now I'm talking about isodiaphers. Isodiaphers are the set of nuclides that have different number of protons and neutrons, but there is same difference between the number of protons and the neutrons. So what are isodiaphers? First of all, I'm writing these are the atoms of different elements. First of all, these are the atoms of different elements having different number of neutrons and protons but what will be common in them? But they will have same difference between number of neutrons and number of protons. Let me take an example for you. I am taking the example of thorium and uranium. I am taking an example of thorium and uranium. First of all, what is the atomic number of thorium? It comes out to be 90. What will be the atomic number of uranium? It comes out to be 92. Now let's talk about the mass number of thorium. It comes out to be 234. And what's the mass number of uranium? It comes out to be 238. So now first of all, let's calculate the number of electrons, protons and neutrons in these two. I'm writing the number of electrons will be 90 in case of thorium. Number of protons will be again 90. And number of neutrons comes out to be 234 minus 90. And it comes out to be 144. 234 minus 90. It comes out to be 144. Now let's talk about number of electrons in uranium. It's 92. The number of protons in uranium comes out to be again 92, and the number of neutrons comes out to be 238 minus 92, and it comes out to be 146. It comes out to be 146. So now what I have to calculate? I have to calculate the difference. I have to calculate the difference between the number of neutrons and a number of protons. So let's calculate the difference between number of neutrons minus number of protons. How many neutrons are there? 144. How many protons are there? Comes out to be 90. So it comes out to be 54. Now let's calculate the difference between the number of neutrons and protons for the uranium, and it comes out to be, in this case, neutron minus proton, it comes out to be 146 minus 92. This comes out to be again 54. So you can see that in these two cases the difference between the number of neutrons and the protons is same. That's why thorium and uranium are isodiaphers for each other. So that's my topic for today. I'm revising my topic from isotopes. So my dear students, what was the isotopes? These are the atoms of same element. Obviously they will have the same atomic number, but they will have the different mass number. I have given the example of protium, deuterium and tritium. Now, what's the isobars? These are the atoms of different elements having different atomic number, but they will have the same mass number. I have taken an example of argon and calcium. And case of isotones, again these are the atoms of different elements, but they will have the same number of neutrons. And in case of isodiaphers, these are the atoms of different elements having different number of electrons, protons, neutrons, but they will have the same difference between the number of neutrons and the number of protons. So I hope you all understood today's lecture. If any student wants to book a paid class for clearing their doubts, they can contact me. My phone number is mentioned on the thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.